Assalamualaikum and salam sejahtera. Welcome back to our topic on MEC111 static. Today we're going to talk more on chapter 6 analysis of structure by using the method of join. In a method of join, what we need to do is to evaluate force by individual join and to treat each join as a 2D particle. The assumption that we need to do is all members are in tension, thus force must be directed outward. For example, here we have a body, and what we need to do is to draw each individual joint, showing that all the forces acting on the joint and all the unknown forces are pointing outward, as in these figures. When solving using this method, there are several steps to consider. The first step is to draw the overall free body diagram. The function is to find the reaction force at the support. During this process, there are several things you need to know. First is to identify the type of support that we have. Then must be able to draw the forces acting on the support, and to solve it by using equation of equilibrium, rigid body, and we have summation of force in Fx equal to 0, summation of force y is equal to 0, and summation of moment equal to 0. The next step that we need to do is to draw the free body diagram for each joint with the assumption that all unknown forces must be pointing upward, as shown in these figures. The third step is to find force for each member of the truss. Start with joint with only two unknown force. We can find the unknown force by using equation of equilibrium particle, such as summation of force in x direction is equal to 0 and summation of force y is equal to 0. So let's implement the step that we have learned. In this example, the truss is pin connected at A and has roller at D. Determine the forces in each member and state whether the member is in tension or compression. The first step that we learn is to draw the overall free body diagram. So we have the figures and then we draw the free body diagram. Here we must understand or identify the type of support that we have. In the example, it's clearly stated that we have a pin supported at A and a roller support at D. By referring to the previous chapter, we already know the kind of reaction that we're going to get for each individual support. For pin support, we're going to have two reactions acting on it, which is in force in X and a force in Y. And when we are connected to a roller support, we're going to have one forces acting on it, which is acting normal to the surface. In this case, it is normal in the Y direction. That's why we're going to have one force acting on this. So the next step is to solve it by using the equation of equilibrium. Here we're going to solve it by using equation of equilibrium. To start with, we always best is to select a point where we can do a moment. The point selected must be the point where there is too many unknown. In this case, we have three unknown, which is FAY, FAX, and FDY. So it is best to select a point at A because when we do the summation of moment, we only dealing with one unknown force, which is FDY. FAY and FAX will be not included in the process because when we do the moment, there will be no perpendicular distance to the point, which eliminates the unknown at A. So when we do the summation of moment at A, we're going to have this force 12 kN with this distance 10 meter, this force 12 kN with the distance of 26, and FDY with the distance of 10 meter. By solving the equation, we're going to get FDY is equal to 43.2 kilonewton. So we proceed with summation of force in x direction. Since we only have one forces acting in x direction, which is FAX, so FAX will be equal to 0. To find force in AY, what we need to do is to do the summation of force in y direction, which we have force AY, force dy, and negative 12 kilonewton and negative 12 newton, which is here, 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 and here. By solving the equation, we're going to get negative 19.2 kilonewton. In this case, it is negative. It shows that the force actually acting downwards. The second step is to draw the free body diagram for each joint. In this example, we have 4 points, which is point A, point B, point C, and point D. At each of the point, we're going to draw all the forces acting on it with an assumption that all unknown forces must be pointing upward. As you can see at point A, which we have 4 forces acting on it. First one is the FAX, which we already find earlier, and FAY with 90.2 downwards, and 2 unknown forces, which is FAB and FAD. The unknown forces, as assumption, it must be pointing outward. At point B also, we must do the free body diagram, which we have a force acting on it with 12 kilonewton downwards, and 3 unknowns, which is pointing outward. The third step is to find the force for each members. To start with, we select a point where we have only 2 unknown forces. We can use the equation of equilibrium particle in order to solve this. We select point A because point A only have 2 unknown, which is FAB and FAD. By using the summation of force in x direction, we're going to have 3 forces acting on it, which we have FAX, FAB, and FAD in X direction, since FAD is moving or pointing in an angle. So FAX plus FAB and FAD in X direction. By solving it, we're going to get two unknown in the end, which we have FAB and FAD. To solve it, we can proceed by using the summation of force in Y direction, which we have two forces acting on it, which is FAY and FAD in Y direction, which we here. So by solving this, we're going to get FAD is equal to negative 52 kilonewton. So the negative sign shows that the members is in compression. Substituting the force FAD into the equation, so we're going to solve for FAB, which we're going to get FAB is equal to 48 kilonewton. So it's a positive sign. It shows that the force in the members FAB is in tension. Next, we move to point B. Here at point B, we have three unknown, which is FAB, FBD, and FBC. However, we already find the value of FAB in the previous point, which is point A. By using summation of force in Y direction, we're going to have only two forces, which is 12 kilonewton pointing downwards and FBD. By solving that, we're going to get FBD equal to negative 12 kilonewton. The negative sign will show that the force in the members are compression. Proceed with the summation of force in Y in X direction. So we're going to have two forces, which is FAB and FBC equal to 0. The value of FAB is 48 kilonewton, which we already find earlier. And then by solving it, we're going to get FBC is equal to positive 48 kilonewton, which shows that the members is in tension. We proceed with point C, where we have two unknown forces, which is FBC and FDC. However, FBC, we already find the value, which is 48 kilonewton. FDC is pointing in an angle, so we need to resolve force FDC into X and Y component. To find the angle, you can use the trigonometry, which we have in the figures below. By using summation of force X equal to 0, we're going to find FDC, where we have FBC and FDC in X direction. By solving it, we're going to get FDC is equal to negative 15 kilonewton. The negative sign will show that the members is having a compression. We can also find force in member DC by using summation of force in Y direction. In Y direction, we only have two forces, which is 12 kN pointing downwards and FDC in Y direction, which also give the same answer, which is negative 15 kN compression. Here is another example that we can practice on the steps. A truss is supported with pin A and a roller at D. State 1, 0 force member in the truss. Determine the forces in each members of the truss and state whether the member is in tension or compression. First step is to draw the overall free body diagram. Here, we must identify the type of support that we have. In the question, it clearly states that we're going to have a pin supported at A and a roller support at D. So we draw the forces acting on the support based on the type of support that we have. As pin support, we're going to have two reactions at it, which is AX and AY. At D, we only have one forces acting on each, which is dy. Next, we're going to solve it by using the equation of equilibrium rigid body. So, first step is to select a point to do the moment. So, it is best to select a point where we have too many unknown. In this case, we have point A, which consists of two unknown, FAX and FAY. By doing the summation of moment at point A, we're going to solve for force dy, which is 15 kN. By using summation of force in X direction, which we have force FAX and the 5 kN over here, we're going to find FAX is equal to negative 5 kN. In this case, which shows that the negative sign, it is moving to the left. To find FAY, we can use the summation of force Y is equal to 0, which we're going to have FAY and FDY. By solving that, we're going to get FAY is equal to negative 15 kN, which shows that the force is pointing downward. Next is to draw free body diagram for each joint with the assumption that all unknown forces must be pointing outward. Here we have 4 points, which is point B, point C, point D, and point A. So shows all the forces acting on the point or joint. The third step is to find the force for each members. So to start, we only select a point where we have two unknown. Here, we select point B, which we have only two unknown, which is FBC and FAB. As you can see, FBC is at certain angle. So by using the trigonometry, we find the angle that we need. By using summation of force in X direction, which we have the 5 kilonewton, and FBC, which is in X direction, we're going to solve FBC, which is negative 7.07 kilonewton. The negative sign will show that the force is compression. By using summation of force in y direction, we're going to solve for FAB, which we have two forces, which is FAB and FBC in y direction. So by solving it, we're going to get FAB equal to 5 kilonewton. So the positive sign shows that the members are in tension. Next, we move to point A, where we have three unknown, which is FAD, FAC, and FAB. However, we already find the value of FAB, which is equal to 5 kilonewton. So it left us with only two unknown. Here, as we can see that FAC is moving at certain angle, which we can find the angle by using the trigonometry. By using summation of force in X direction, we're going to have three forces, which is FAX, FAD, and FAC in X direction. So by solving it, we're going to get FAD is equal to 0, which is the zero force member. Using the summation of force Y equal to 0, we're going to have three forces, which is FAY, FAB, and FAC in Y direction. So by solving it, we're going to find FAC is equal to 11.18 kilonewton, shows that the members are in tension. So the last point is point D, which we have two unknown, which is FAD and FCD. So FAD we already find, which is equal to 0 kilonewton. So it left us with FCD only. Since FCD is only moving in Y direction, by using summation of force in Y direction, we're going to get FCD is equal to negative 15 kilonewton, which shows that the force or the members are having a compression. With that, we already solved all the forces acting on the members. With that, we already finished with the steps in solving a problem in truss using method of joint. Hopefully, this video will help you on solving the problems. Hope to see you guys again. See you in the next video. Thank you for watching. Don't forget to subscribe and click the like button. Bye bye.